So everybody always tells me the same thing. You can build greenfield projects with AI, but you can't work with AI on enterprise, large, duct taped together code bases. Well, that's why this week at Gauntlet, we took open source repos that hadn't been maintained in years, millions of lines of code, legacy Python, PHP, and even Fortran. And we used AI to make significant improvements to those code bases. So Austin made a bounty. He said the student who was able to make a significant improvement to a legacy COBOL, assembly, or Fortran repository would win $1,000.
Oh no, we're giving out a bounty. So anyone that builds something with Fortran or COBOL or assembly, we're gonna pay him cold hard cash.
Now, we started looking for COBOL repositories. We started looking for assembly repositories, and we didn't find any that were open and available, but we did find many Fortran libraries. So there are a select number of students who are using that as a way to test if AI can actually work on top of Fortran. I'm reporting here from Gauntlet HQ. It's like midnight, and Nick is working on a Fortran repository. First and foremost, let's ask him, what the hell was he thinking?
I was in it for the challenge. And also, Austin offered people money, so I was in it for that too.
So have you ever worked in Fortran before?
No, never read it, never written a line. I've heard of it. I did not know that it is actually very popular nowadays in scientific computing. There's a bunch of it in very active use.
And it's actually the only thing that we were able to find for Austin's challenge. So you'll notice that every one of the Fortran repos are like quantum mechanics, mathematics, something like that. So did you think AI was going to be able to help you at all on this challenge?
So yes, some authoritative people here were skeptical. And I heard them making various comments, and I was not skeptical. I was pretty sure that, it was going to work.
So, this is a challenge out to the world as well, because all those people who say, hey, AI doesn't work on legacy code bases. Well, Nick, did it work?
Yeah, kind of. Yeah, it did.
So what did you do? So walk us through the steps.
Yeah. Okay, so originally we were thinking about doing COBOL, but we couldn't find any COBOL libraries, and so we sort of broadened the scope of what we were looking for to Fortran and assembly. And so we were looking for Fortran. Am I saying that right? I'm real tired.
I want everybody to know that it's midnight right now. Okay, cool.
Fortran.
Fortran.
Fortran. I keep saying Fortran.
Fortune.
I lost my train of thought now. But we were looking for libraries to find. There were a bunch of open source ones. I, of course, went off the beaten path and found an abandoned scientific computing, like a mathematics library from the 90s called Slaytech. Great name. I was playing around with it. So I had like 4 different things open because I didn't know. I was very indecisive the first day. I had the Weather Research and Forecasting library open. I had the LAPACK library, which is sort of a slightly outdated scientific computing library. I had this Slaytech library open. And then I also had like some kind of retro gaming assembly extraction of Pokemon Red, which I was actually leaning towards that. In the Slaytech library, I'd had the idea of, so the Slaytech library is from the 90s, and it was written in Fortran 77, and the modern Fortran is Fortran 90, and it is kind of like not like an old language. It has a bunch of like modern developer affordances in the language that make it nice to use. And so I kind of had the idea, what if I took this old mathematics library and I migrated it from Fortran 77 to 90.
For the, let's say, less technical people watching, a migration from Fortran 70 to Fortran 90, could you describe what that actually means in terms of, let's say, work?
So basically the language has been almost completely rewritten. Over the last 50 years, the language has evolved considerably. Any code written in Fortran 77 is kind of unrecognizable. I looked at examples and I was like, these are different languages effectively.
In terms of like context engineering and AI, how does one even like start to like migrate a language as you did?
Well, the first thing is understanding kind of what's in the library to begin with. Because like I downloaded the library from a repo and I had no idea what was even in there. Like just clicking through the different files, it's all like, to my eye, unrecognizable. I don't know what any of these things are and I don't know how any of them work. And so the first thing is you just lean on AI to say, what am I even looking at? It's a little bit difficult to show because there's no UI. We're just looking at a mathematics library. I'm a Tmux guy. I use it for tiling, which is not what it's for, but that's what everybody uses it for. So we have these 4 different tiles. This is all the project. I'm only doing work in the bottom right. The other 3 are all various things related to an amusing incident I had with data validation. So when you translate these math functions from 77 to 90, like you can ask the LLM to generate whatever code you want, but the issue is, does it actually work? And does it do what the original code does? Now, I was, fortunate enough that these are math functions, and so the new one should just work the exact same way as the old one. So like, oh, that's great. You have tests and you just generate the code, and if the tests pass, no, there are no tests. And so what I did was I wrote code to fuzz, which I'll explain. Old Fortran 77 code, like the different math functions, is basically where you take like a wide range of inputs, you send them into the old code, they all generate outputs, and that mapping becomes your test cases for the new code. So if the new code passes, like gives the same outputs for the same inputs, you're good to go.
Did it work?
No, it didn't work. So there was actually a problem with the way I was generating these test cases. The original way that I did it was I had a Python wrapper around the different Fortran functions, and I would use that to feed the input out, and I would serialize the output. And I had the old code that I was feeding inputs into it, and there were outputs, and I don't know where I was.
I have decided to build in Fortran. I did not do it for the sake of the challenge. I actually was uninspired by some of the other options until I saw Quantum Espresso, which is a Fortran project.
What does Quantum Espresso do?
Excellent question. It is a quantum mechanics simulator used primarily for molecular modeling. Computational chemists use this, and I have a degree in chemistry, so I've touched things similar to this before. I'm a little familiar with the workflow and some of the computations that are done. Quantum Espresso sounded familiar. I don't think I grabbed that one. I grabbed something similar, and I couldn't even install it at the time. And it's very hard to use. The experience is quite clunky. For this, I actually understand a bit of the typical workflow. And so I'm actually trying to build for the typical user, the power user, and add some features as though I work on this project.
So with somebody trying to use AI to build with, let's say, a legacy coding language, what tips do you have?
Plan, a lot of planning. I didn't try to code. I didn't touch the code for the first day and a half. I spent a lot of time having AI go through the code base, directory at a time. Since it's a huge code base, there's so many files. How do files interact with each other? How do they compile? I tweeted this out. I had Grok. I said, write me a really simple Fortran program, double a number, take an input from the command line, double a number, and print it out. And it took 3 attempts to get something working. So even that simple doubling a number was too tough for Grok. As I've been working, I've gotten a feature or 2 added so far, and that has been the biggest struggle. It seems like for every prompt where I have it write code, there's like 5 more prompts where I'm copying the error message from when I try to build the whole system. So I build frequently if you're working with something like Fortran, something that compiles. And then the other thing that I think is helpful, I had Grok give me a set of tips, best practices for working in a legacy code base, a big code base that writes Fortran 90. And then I put that file in the code base, and then I had Gemini from the command line read that file, and then it was able to look at a few files in the code base that already existed and kind of refine the tips a bit and say, oh, actually, the people who wrote this use a slightly different formatting, or made some different design choices. So I crafted a beautiful prompt to give to Claude, and I said, here are the best practices. Here is the architecture of this code base, because you're not going to be able to read everything. Here are the things we're doing. We have access to Taskmaster's one of my favorite. Quick plug, Taskmaster is the best command line tool for working with AI. It creates tasks that kind of persist throughout every session so that you can make sure every time you start a new chat, you make sure the AI is immediately up to speed. It can see what's already been done, what is still to be done, and what it should work on next. So anyway, crafted a beautiful prompt, and I am using it every time I start a new session. And it's a slow process, but we are making progress.
Howdy, how we doing?
What do you think about this week at Gauntlet AI?
Ooh, it's a little challenging. took a little longer to get started with these legacy code bases, but now that we are rolling,
What's a legacy code base?
it's one of these like giant, in our case, abandoned code bases that have like over 1 million files for the project that we're doing. And you're kind of like, the big question with AI is can it handle changing and working with code instead of just starting anew with like these greenfields. So I don't know, we're testing it now. We're going to see if we can make some significant changes.
You don't sound confident for the submission deadline tomorrow.
There's a submission deadline tomorrow.
I meant today.
No, I got a Docker container running. That's all that.
We have a Docker container running.
Well, come on. I mean, hey, we still got a little bit of time. I'll get it by Sunday. I'll get it.
Hey, David, catch.
Howdy. Well, it is 11:30 at night, and today was a big day in the Gauntlet because not only did we have our project submissions for our legacy codebase week, but we also had hiring partners come in today. A bunch of us did back-to-back interviews, and so we were juggling the two great things about Gauntlet. One, cranking out code, and two, getting to meet killer companies that are AI first and want to have AI engineers join their team. So feeling tired, but feeling good.
What week are we in now?
We are in week 6 out of 10. And so we're on the back half. And honestly, I just want to squeeze as much as I possibly can out of what is left.
Howdy, folks. What do you want me to talk about? A lot of people are looking at meta orchestration of agents. I'm kind of moving to that flow, basically orchestrating a bunch of Claude Code instances or AMP instances. I'm currently got an agent setting up a script so I can deploy the new Quen model on Lambda. Lambda Labs, they have GPU clusters. But it's late and a little delirious, so join Gauntlet. October 13th, don't miss it. Cohort 3, let's go.
Yeah, buy a Mac Mini and start some swarms. It's a bunch of agents working at the same time to solve a task or multiple tasks that you could spin up or down. Anyway, just build with AI. This is the most exciting thing. There's nothing else that you could be doing at this point in time that is anything that could be remotely as interesting. The world is just changing as we know it. Jump in.
Now, this is important. We believe that in education, often the incentives are not aligned. The point of Gauntlet is that everybody in this building is working to get you hired, and we want to make sure that we match you with the best hiring partner possible.